seen this error message before? Let me explain in detail what it means. Some time ago, I made a video on this channel in which I used WinDBG to analyze a memory dump that was generated from a blue screen. The memory dump that I used in that video had the infamous error code IRQL not less or equal. After searching around on the internet for solutions, I found a lot of misinformation about this particular error code, a lot of tricks and a lot of theories of what it means. So let me share my insights on what exactly this error code means. First, we will see a brief demo of this blue screen of that error code in WinDBG. Then I will explain what this error is not, what exactly is this error, and how do we go about fixing it. Let me quickly switch to an instance of WinDBG that I have ready. What I've done is I've already opened the memory dump, I've put the symbols, and I've run analyze-v. Let's scroll up to the top of the analysis to see where the confusion is, which is this error code over here. Driver IRQL not less or equal. The confusion with this error code is actually the IRQL. IRQL does not mean interrupt. It actually means interrupt request level, which is a different thing than an interrupt. But first, let me explain what an interrupt is. An interrupt is a feature of a CPU to run a function when something happens. I am overgeneralizing. There is much more nuance, but that's pretty much the high-level description. When an interrupt is raised, some code runs. This is how the CPU signals programs to run when something happens, like a network card gets data or a hard disk has completed writing. This number in the dump is not the interrupt. This is the interrupt request level. The actual interrupt can be viewed in Device Manager over here. What you're seeing in WinDBG is actually the dispatch level, also known as the IRQL, interrupt request level. Drivers, when running, have a dispatch routine or IRQL, which is their dispatch level. Now, I'm overgeneralizing what this is, but it's pretty complex to explain what these levels are. But what I want to get across is that they do not actually represent interrupt numbers. They are actually levels that control how much a driver can do or what the driver can access. The important part with regards to this particular error message is that if a driver is running at dispatch level 2, it can only access memory at certain low memory addresses. This is the scheme in which drivers have to adhere to when running in Windows. The true reason why this scheme exists is because of virtual memory. When a driver is running in Windows, it's running at a certain ring level. Ring levels are like hardware security levels. The driver is not allowed to access any memory that would be paginated by virtual memory. The reason is, if the memory is not available, the driver will crash. Hence, it is limited to just the lower order memory, which is always going to be present and not in virtual memory. The scheme is really complex, and I don't want to get into it in this video, but just remember that if it is an IRQL error which is of 2, it means that the driver should have been accessing memory in the lower order, but it went above it, hence the error code. This is the key reason that the IRQL in the memory dump will say 2. It's because this is the dispatch level that it has been assigned to this driver. The value for argument 3 over here says 0, which is read. That means this driver attempted to read memory from this location in argument 4, which is above the limit that is allowed to read when it's at that dispatch level. This is very common because, again, drivers are not allowed to use virtual memory unless they are at a particular ring level, and in this case, this driver is not assigned that particular dispatch number, So it is not allowed to use memory in virtual memory. It must restrict itself to just memory that is physically located. Hence the lower order memory. Now, technically, the driver can actually raise its IRQL level, and it can also lower its IRQL level by itself if it needs to go and access memory in other locations. I don't think this is going to be that relevant. If drivers are capable of doing that, they probably have a memory management scheme that would work. If you get a memory dump that actually says dispatch to, it probably means it's dispatch to that has caused the problem. So, what can we do about it? Let me switch back to WinDBG. So, now we know that it is the dispatch level, and we know that it's reading memory that is out of scope. So what exactly is causing this error? Well, it's pretty easy to explain. It's just a dangling pointer or a pointer that is just pointing to garbage memory. If this were to occur in a standard application which wasn't a driver, this would be an access violation. All it is an access violation where a pointer cannot read a block of memory. Now, if you have a pointer which is dangling and is pointing to some random garbage memory and the pointer reads it, it will just get an access violation. But in a driver, there is a check. And that check is if the memory address is allowed to be read. And if it's not allowed to be read, the error code is very specific. So in the case of drivers, because they're so restrictive, an access violation is reported with a different error code. So in this example, it is going to report IRQL not less than or equal. It doesn't actually mean anything's wrong with the interrupts. It just means that there is a dangling pointer and it would have been an access violation. Okay, so how do we fix it? Well, the good news is it's probably something wrong with the software. So upgrading the drivers to the latest version is probably going to fix it. The reason is that this kind of error literally means that the pointer was garbage, or the pointer was too high, or the pointer could have been a value that was being read after it was supposed to be deleted or freed up. This kind of points to a software error. However, there is a slight chance that it is a hardware error and the hardware is delivering values into the driver which is invalid. It is a small chance because if there was a hardware error, the blue screen will actually say something about the hardware. Maybe the clock was not working, or it had hung, or something to do with the bus. It's quite rare to get this error on hardware because how would the hardware have worked so well to let the driver run but yet put a bad value in a pointer? Generally, it leans towards a software error. So, if you ever see this memory dump, just upgrade all your drivers, and if that doesn't work, assume it's a hardware problem. It's a rare chance, but it could be. I made this video because when I was searching on the internet for solutions to my previous video, I found so much misinformation, and a lot of it was because IRQL, people assumed it was interrupts. So they went around tampering with their Windows. They changed their interrupt settings, they tried to move their hardware around, they did all those hardware oriented things thinking that this memory dump aims towards hardware. This kind of memory dump aims towards software. Upgrading your software, making sure Windows is the latest version, making sure your drivers are the latest version, those are the things you should do first. Assume it's a hardware problem only if you get different kinds of memory dumps, or if you can prove that the dump is becoming random, like one time you get one error code, another time you get a different error code, then assume it's hardware. If it's consistently giving you this particular error code, assume it's software. Anyway, I hope this video helped. I have seen this kind of memory dump many times because when I wrote drivers in the past, I created most of these problems because it's really hard to debug a driver, and having a dangling pointer here and there, well, it happens. And so I saw this error code really a lot of times. So I thought I might as well make this video to just tell people that it's probably just software. Don't worry about your hardware, it probably works. Generally, you see this kind of problem when people are setting up graphic cards, where they download drivers and they don't really know what works, so they just install all the drivers and then something bad happens and then it crashes and then they forget to upgrade. So usually I just recommend this is not the time to panic. It's not a hardware issue, it's a software issue. However, it could be a hardware issue, you just don't know at this point. Anyway, let me know in the comments below if you have seen this kind of memory dump before. I have been overgeneralizing for this entire video, skipping over all the details, so definitely let me know if you spot a mistake or if you want to correct me about something. Just lay down in the comments below and I will read it, because I skipped over a whole lot of complexity in trying to explain what this particular error code was. Gentle reminder to subscribe, hit that bell icon and give me a like if you like the content. As always, it's been a pleasure bringing you this information. I am High Voice, signing out.